the ranking with repetition. Again, when we have to rank this again, maybe repetition would be more than 2, more than 3, and so on, right? So how this would start? In the dictionary itself, we know that we can write this as AAGIN. So first we have to get this with A only. So at the first place, A is already there. So A will be there, right? But we have to arrange these four, right? A, G, I, M. And that has to go for G, A, I, M. So first we have to make all the words from A, right? We know that if A is there, this 3 will be mixed with 3P3 or factorial 3. So now the place A will be there. Then with the dictionary, I know ki I will be coming there. Then again, I and then right again. So only we have to change for first places it was there, right? Only we have to change the 4, right? So this 6 and this is 1. Or for any repetition, right? Will later on we'll go again on this, right? First, we want to see the different terminology in permutation and combination, and the name itself shows that this combination is one of the important terminology that we have to understand. Each of the groups or selection which can be made by taking some or all of a number of a thing without reference to the order of the things in each group is known as combination, right? Each of the group or selection which can be made by taking some or all of a number or a thing without reference to the order of the things in each group is known as combination. So when we were studying about the permutation, the order was important. You have to select them and then arrange or rearrange them, right? But in combination, only the selection process will be there, right? Only we have to select these things. only the selection part, not the arrangement part. So we know that if n things are there and places places are there, right? And we have to fill these R parts by n. So we know this in permutation, we did this like NPR. NPR means arrangement of R things are there, right? So arrangement of R things happen with factorial R ways, right? So if we want to go for combination, so these R factorial is of no use. So for combination, this will be NPR upon factorial R. We have to reduce down the arrangement of the numbers, and this is known as NCR, or the formula for NCR will be factorial n upon n minus r ka factorial r ka factorial. Right. So this is the formula for combination. NCR factorial n by factorial n minus r into factorial r. And like the difference between this permutation and combination is, in this arrangement is required with selection, and in this only selection you are doing, then you have to write down this as NCR. So selection and selection with arrangement, right? So what type of question we can frame and write? Only the selection part. So let's suppose I'm giving you red house, only one captain we have to select out of the student, right? Let 40 students are there, and we have to select a captain from this, right? And one vice captain also. In how many ways we can select captain and vice captain? So first, we have to select two members. So 40C2 is the selection of two members, right? So two members, right? Let two person are coming as R and Q. Let ये दो मैंने सिलेक्शन कर लिए, right? अब ये दो जो सिलेक्शन मेरे हो गए, इसमें we know that ये दो सिलेक्शन जो मेरे पास है, one will be captain and other will be vice captain. So if this is R and this is Q, so R will be captain, then Q will be vice captain. Or if I'm saying R will be vice captain, Q will be captain. So also two means here we have to select as well as arrange. So selection as well as arrangement in this case. Okay. Question second on this. in how many ways can 7 different books be given to 2 students if one student is to have 4 books and other is to have 3 books, right? 7 books are there. We have to distribute these 7 books as one having 4 and other having 3 books, right? So in how many ways we can select the books? So these are the 7 books, right? For first student, you have to select 4 books, and for second, you have to select 3 books. So if I'm selecting 4 books for first one, right, out of 3, the second is going there only, right? So with the selection only, we can say, okay, these 4 books are coming for first student or second student, right? Next question, third one. A teacher takes 3 children from her class to the zoo at a time. As often as she can, but she does not take the same 3 children to the zoo more than once. More than once, he finds that she goes to the zoo 84 times more than a particular child goes to the zoo. Find number of children in her class. Take your time, think for 2 minutes how to go for this, then I am giving you the answer. A teacher takes 3 children from her class to the zoo at a time as often as she can, but she does not take the same 3 children to the zoo more than once he more than once she finds. But she goes to the zoo 84 times more than a particular child goes to the zoo. Find number of children in her class. See, the first thing here it is given that 3 children are going to the zoo as often as possible, but no 3 are going more than once, right? So same combination will go. So if we can suppose this total number of children in her class is n, right? So in how many ways she can select 3 kids out of n? So we know this will be only nc3. So total number of ways that she can select 3 students out of n will be nc3, means nc3 is the number of ways we can say like the students selection is same as she is going to the zoo, right? Every time she has to go with a combination of 3 students. So total number of combination is nc3, right? So maximum times she can go to the zoo is the maximum number of group of 3 children she can select out of n. So this will be nc3. This nc3 is for, right, how many times he is going. But in the condition, this is also given that the second form, right? She goes 84 times more than a particular child goes. So out of these 3, I'm saying, okay, we have to pick this child, right? So total number of students, if I'll pick this one key, this he has to go, right? So this particular child is there. So now the number of child will be n minus 1. And out of this n minus 1, 2 students will go with him, right? So one particular child is this one. So if one particular child is this one, so 2 more member we have to choose from n minus 2. They will accompany him to go to the zoo, right? So now total number of a particular child is going is n minus 1 c2, right? So this the case when n minus 1 c2 is a case when a particular child is going to the zoo, and this is the case when, right, the teacher is going to the school. So what question it is given that nc3, right, c is going to the particular child is 84 times, right? nc3 minus n minus 1 c2 is going to be 84. Now we have to solve this for n. Now since through the Pascal triangle we know that n minus 1 c2 plus n minus 1 c3 is nothing but n minus 1 plus 1 c3. So, and this is NC3. So NC3 minus N minus 1 C2 will be N minus 1 C3 is equal to 84. Okay, so only the calculation part in this, right? Easily we can go with the numbers. This is the combination. When the combination, this type of combination with conditions are given, or two combinations are given, when we have to solve this, right? We have to solve this like suppose there are 10 social worker and we wish them to work in a group of 2, 3, 5. How many ways can we split them up into groups of a right size? 10 social workers are there, right? And we need this, right? It has to be divided into three parts, right? In how many ways we can divide this? See, so what we have to do in this case, right? 10%, we have to take this out too, right? So we have to split them into the groups like 10C2 first, and second will be, right, out of 10 we have already taken 2, so we have 8, so 8C3, and now this will be 5C5. First we have to take 2 out of 10, then rest are 8. From 8 we have to make the group of 2, then 3, and then out of 5 we are going for 5. This is 1 only, and this is 8C3, and this is 10C2. Right? So accordingly we have to just go for 10C2, 8C3, and 5C5. Now, if I'm giving you, there are two houses, red house, blue house. There are 40 students in this and 50 students in this. We have to select 10 students from this group, and we have to select 5 students in this group. in how many ways we can select? In how many ways we can select the total of 15 students in this group? It's a very simple question. Hope everyone is getting this. So from this red house, we have to select 40C10, and from blue house, we have to select 50C5. So this is the total number of selection, what we have to do and what we can. Right, 40C10 into 50C5. Right, with the restrictions also, if we have to select, right, in the simplest way we can go, right, one more. See, India and Australia match is going on, right? So let's frame a question for this. Out of 16 players, we have to select 11, right? In these 16 players, we know that two are wicket keeper, right? 6 bowler, 6 batsmen, and 2 all-rounder. And management decide that they will select, right, only one wicket keeper, right? We'll go with 4 bowlers, right? And 2 all-rounder all, and 4 batsmen. In how many ways we can select our team? In how many ways we can select our team of 11 players out of 16? Particularly in this case, we have very good selections, right? And the selection process will end when we can select all the possible ways, like start with the combination, start with 6 to 4, right? This will be with the multiplication only, 2 with 2, out of 2 1, out of 6 4, right? So number of ways we are getting this. The process will continue till the end, then you have to multiply, right? We are using the multiplication theorem, right? The multiplication theorem on this. Okay, so one more. In a group of students, there are 4 boys and 5 girls. We have to select a team that consists of 3 boys and 4 girls, right? 3 boys and 4 girls. In how many ways we can select? In a group of, right, 9, out of 9, 4 are boys and 5 are girls, we have to select a team consist of 3 boys and 4 girls. In how many ways we can select the team? Right, first question. So obviously this will be 4C3 into 5C4. Right, out of 4 you have to select 3, out of 5 you have to select. Second question, at least 3 boys and 4 girls consist in the team. At least 3 boys and 4 girls, right? So when we are using at least word, right? So for at least word, right, we have to go with, right, total number of boys, 4 boys and 5 girls. 5 girls. Case first, 3 boys, 4 girls. Case second, 3 boys, 5 girls. Case third, 4 boys, 4 girls. Case fourth, 4 boys, 5 girls. So we have 4 options, like the options are there. So first is 4C3 into 5C4. This is 4C3 into 5C5. This is 4C4, 5C4. And this is 4C4, 5C5. Right? We have to add all the quantity what you're getting out. Please see this carefully. First, the case for exactly you are selecting. Second, the case when we have to select at least with the condition with we have to start with the minimum and goes to the maximum one. Very simple, right? Okay. So if we want to proceed this as like the combination one or the selection one, if you remember the question, one question just I'm showing you for, like this we have already done in binomial theorem, right? You know this. NC naught MCR plus NC1 MC R minus 1 plus NC2 MC R minus 2 and so on up to last term NCR MC naught, right? If you remember, the summation of this is nothing but N plus MCR, right? So now see this, the with the same combination, right? Boys and girls question, how we can go with this, right? Let, what is this given? What this condition is given, right? It is given NC not MCR MC. So let a group red house that contains n students, and second is blue house that contains, like in this section, m students are there, right? And we have to select r students from the group, right? So when we have to select r student, case first, 0 coming from red house, r coming from, right? Case second, 1 coming from this, r minus 1 coming from this. Third, 2 coming from there, r minus 2 coming from this. Fourth, 3 coming from this, r minus 3, and so on. Up to the last one will be the rth one. This contain r and this is 0. So this is the condition, right? So, and 100%, this is written there. NC not, first condition. Second is 1 and r minus 1. Third is, and the last one is this one, right? So this is called a combinatorics argument, right? Combinatorial argument, right? How we have to make the argument. Now, look, the second thing, what I'm saying, okay, red house and blue house, dono ko maine, like we are combining both this. Red house and blue house, we are combining both this. So how many students are there? The total number of students now is m plus n. And out of this m plus n, how many we required? How many we require this r? So 100%, in the other word, I can say m plus n c r. And this was the answer of this. So with a single thought process, we can solve this, right? With a single thought process, we can solve this, right? Only we have to change our mathematics into, right, into a situation where we can, right, discuss the thing, or easily we can get the answer. Hope everyone is getting this, right? If yes, you can write down in chat. Right? Very good, very good. Now, the second type of question, next, for the combination, is called the playing cards question. Playing cards question means, we know that the playing cards, total number of cards, total number of cards 52. This is divided into 4 parts, right? Spades, heart, diamond, and club. Diamond, spade, hearts, and club, right? With the numbers, each one contained a ace, then 2, 3, 4, 5 up to 10, then jack, king, queen, right? So total 13 card in each, right? 13, 13, 13 cards are there, right? Few terminologies are there. So first terminology for playing cards is face card. Face card means ace, j, queen, and king, right? Second is right numeric card. Numeric card are the number 2, 3, 4 up to 10, right? These are called the suits, right? These are called the suits. suits, this diamond, spade, hearts, and club. Right? So few terminology we have to remember, like not a very much, but honor card are the cards that's honor card is going for this, right? But remember, in face card and like few of the places you will find only Jack, Queen, and King are called the face card, and this is called the honor card, right? So it depends on what terminology we are taking. So most of the case, face card and honor card that distinguish this. So honor card will be with A, J, Queen, and King, and face card J, Queen, and King, right? So these three for usually use, right? And few of the books use this one. So we will take that the complete set is called the honor card, and only these three, if you are taking to, we'll call them the face card, right? They have the face, right? So the question on this, first, what is the number of ways of choosing four cards from a pack of 52 playing cards, right? In which how many first four cards are of same suits. Second, four cards are of different suits. Third, are face card. Face card means coming from, right? Maybe it is given. Two red, two black, right? Up to the song. Go for four questions. You can write your response in chat. It's a simple question. Okay, let's see. The first one, when we have to distribute this out of 52 playing cards, we have to select 4, but they are from same suits, right? First is like how many ways only. So this is only 52 out of 52. We have to select 4. So that will be 52C4. But the same from the same suits. If it is given, it's from the same suit we have to select, right? So how we can select this? The same suits. So how many suits are there? Right. So how many suits? So first we have to see first, second with the club hearts. Now, so these 4 suits are there, right? Each suit contain 13, 13, 13, 13 cards. So we have to select 4 that comes from the same suit. So case first, 4 is coming from this and 0, 0, 0 from there, 0, 4, 0, 0, third 0, 0, 4, 0, and fourth 0, 0, 0, 4, right? So for this, I'm getting 13C4 from this 13C4, 13C4, or 13C4, right? They are from same suits. So this is all are coming as same suits. So 4 times of 13C4, right? First case, second case, third case, or fourth case. Or you can see in this way, first we have to select a suit. So with 4C1, I can select the suits, right? When we have already selected the suits, right, out of 4, I'm going anywhere, like in this or this or this or this, right? So now out of 13, I have to select 4 cards, 13C4. So the both way you are getting the same thing. The logic would be different, right? Maybe the logic would be different, but both way you are getting the same numbers in this way. 4 card belongs to the same suits, right? Next question was 4 cards belongs to the different suits, right? All the cards coming from different suits. So we have already, right, discussed about this, right? So one has to come from this 1, 1, 1, 1, right? This is the only case what we required. And out of like 13 in each, we have to select 1. So out of 13, 1, out of 13, 1, out of 13, 1, out of 13, 1, right? So this I'm getting all are from different suits, right? Third one, face card. So already discussed this face card or honor card. Few of the books use for ace also, but the face card is 1, 2, 3. These 3 are the face card. Out of, we know that every J, Queen, and King contain 4, 4, 4. So total will be 12. Right? Out of 12 cards, we have to select 4. Right? Out of these 12, we have to select 4. So 12C4. Right? And the fourth one, Out of these cards, 52, we know that 26 red and 26 black. And we have to select 4 cards from these 52 cards. 2 are coming from red and 2 are coming from black. So 26C2, 26C2, right? For the 2 black and 2 red cards, right? Okay. Now again, I'm framing in the same question, I'm framing that 10 cards we are selecting from 52 cards such that at least 2 aces will be there, right? 10 cards we have to select out of total 52 cards that must contain at least 2 aces, right? 2 king, 2 queen, anything will be there. This is the selection process. Maybe with the cards, maybe with the boys and girls, maybe with the students, maybe with some balls also. So in this question, we can see that, right, 10 cards we have to select and we have, right, 4 aces are there and 48 non-aces are there. A dash means complement of A, right? Case first we have to select 2 and 8, 3, 7, 4, 6, right? So this will be out of 4, we have to select 2 to 4C2 into 48C8 plus the second case 4C3 into 48C7, third case 4C4 into 48C6, right? This add and add. Few of different things that, okay, why not to take both the both the things as one, right? Two cards of SS are there, right? The main and rest of the card 2 is and 48 non. So out of these 50, we are selecting, right? Maybe 2 are there. So maybe we are selecting 8 there, and maybe we are selecting like 3 aces are there, and we are selecting 1 ace and 48 non-ace, right? So this will be wrong, right? This will be completely wrong because there we are getting the repetitions, right? So 100% when you are going for these type of question, you have to go with each and every case step by step, right? First build this for one, then go for second, then third, and so on, right? And total you have to select 10. So this number, right, this number 2 plus 8 will be 10, 3 plus 7 will be 10, and 4 plus 6 will be 10 only, right? Don't go beyond that, right? Now, there are two bags, bag A and bag B. Bag A and bag B. This contain 3 white and 4 black balls. This contain 3 black and 4 white balls, right? We have to select at least 3 balls from each bag such that at least 3 balls from each bag, and we have to select, right? And the maximum number of ball we are selecting will be 8, right? First, second, out of 8 balls, 4 white and 4 black. When from each bag we have to select 3. Bag A and B, right? First question, when we have to select maximum of 8 balls and, right, both the bags A and B, 3 white, 4 black balls, 3 black, 4 white balls, right? And the condition A, we know that this will be 3, 5, B, 4, 4, and C will be 5, 4, right? So there isn't any condition. So 100% we can go for this as 7C3, this as 7C4, and this we can 7C5 into, in this case, 7C5, 7C4, 7C3, right? All the cases on this. But if there is a restrictions, like in first case, we are saying we have to select, right, 8 balls, 4 white and 4 blacks, right? Then there would be a interlinked cases that will arise, and we have to go very careful in that case. Like in the first case, if I'm saying from bag A we have to select 3 and bag B, we have to select 5, right? And how many balls are there? 3 white and 4 black balls, and 3 black balls and 4 white balls. And total what we required is 4 white and 4 black balls. Just I'm showing one case there, right? So we can relate this how interlinked will be there, right? So out of 3 and out of 5, we have to take out the balls as white and black. So we have to select white and black. We have to select white and black. We know that at least one like black ball we have to select from this. So 1 from this, so 3 from there, right? First case. And in this case also, right, white we can say we have to select 3 balls from this. So 100% we have to select now 2 white. If one is restricted for black, so 100% we have to go for 2 white ball, right? And this B is 3 balls we have selected, and then we have to select 2 only, the first case. What is the answer? How we'll write this? 3C1, 4C1, 3C2 for this, 3C3, right? Out of 3, and this is 4C2, right? 1 black ball. In the second case, I'm saying 2 black balls. If I'm selecting, so I have to select 1 this. So 2 black balls are there. So 2 black balls there, right? And 1 is this. Then we have to go 3 there, and so on. We have to make the cases for the numbers. Okay. So be careful if combination is given in the interlinked way. So we have to solve one by one carefully, right? Next is permutation of alike objects. Permutation of alike objects. What is the meaning of this? See, if I have to arrange A, B, C, these four. So A are alike, but A, B, C are distinct, different. So we know that if A alike and B, C are different, right? So total number of ways, right, this will arrange if both are different, right? I'm saying this is A1, A2, B, and C. So this would be factorial 4. But if both these two are alike, so A are alike, so we know that by factorial 2 ways, there is an arrangement between A1 and A2. So A1 and A2 arrange with this 2 ways, and I'm saying the permutation is P, and total is given as factorial 4, right? Total is given as factorial 4. So now the permutation with alike will be factorial 4 by factorial 2. Or we can say that let P be the required number of permutation in this case, right? If any one of the actual permutation, we suppose that the A are all changed into P letters, right? Different, then it can take the factorial 2 ways, right? And rest are the same in this case. So we have to just see this factorial 2 ways, multiply with the permutation, then we are getting this factorial 4, all different cases. But since these two are alike, these two are same, so we have to divide this. So in overall sense, if I'm saying like 1, 2, 3, 4, 5 up to n, and things are given. Out of this, P are alike, Q are alike, R are alike. Then what is the permutation? How many ways we can, right? We can go for this. And the rest of N minus P plus Q plus R are different, right? Different or distinct. Then how many ways we can arrange this? So The answer in this case will be factorial n upon factorial p, factorial q, factorial r. And rest will be in a different way, right? So this is the formula for permutation of a like object, and you have to divide this by how many ways these are alike, right? So we can convert this into the questions also, right? When the repetition is allowed, like in how many ways we can arrange or permute the letter of the word Vivekananda, right? One of the respectable Indian. So you can try this. In how many ways we can? So first we have to see what are the repetitions. V, two times. Two V's are there, right? A, 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 A. Three A's are there, right? N, two N's are there, right? And the rest are different. One I, one E, one K, one D, right? We have to arrange this. 2 to 4, 7, 8, 9, 10, 11. Total is 11 factorial upon the repetition one, 2 factorial, 3 factorial, 2 factorial, right? So this is the answer what you are getting with repetition. Okay. So now with the numbers, also we can use this, right? Find number of 6-digit numbers not divisible by 5 that can be formed by using the digit of the number 121202. 121202. So this is one of the beautiful arrangement of the number, and like the restrictions are there, as well as the permutation of more than right repetition is there, so that we have to take care of that. We have to use both the things. Like, see, what we have to find first required number is total minus number of arrangements starting with 0, and also we have to subtract number of arrangements ending with 0, right? Starting with 0 will give you, like, if it is 1, 2, 3, 4, 5, 6, any 5-digit number is coming, so that's we will reduce down. And ending with 0 is will give you, like, that's divisible by 5 case, right? So we have to be careful with both this. Divided by 5 also, we have to subtract these two, then 100% we are getting a complete answer on that, right? So let's see how we can go. So total number of arrangement, the number 1 1 1 1 and 2. 2 is 1 2 times, 2 3 times, 0 1 time, 3 4 5 and 6. Factorial 6 by factorial 3 factorial 2 is the total number of arrangement in this case, right? First. Second, starting with 0. So obviously the same thing will be there, but the arrangement of 5 numbers, factorial 3, factorial 2, starting with 0. And third, ending with 0, right? Ending with 0, again, the same thing with factorial 3, factorial 2. So what we are getting is factorial 6 by factorial 3, factorial 2 minus 2 times of factorial 5 by factorial 3, factorial, right? So this could be the answer, right? You can calculate this. Okay. One more on this. Find number of seven-digit numbers which have exactly 3 ones. Exactly 3 ones. Right. It's a beautiful question. Let's try this. I'm giving you 3 minutes for this. You can write down your answer in chat, right? Maximum 3 minutes. Very good. Not many answers are coming, right? See how we can go. The 7-digit number exactly three ones, right? So first we have to go with the 7-digit number. So make the blocks of seven. So one, right, six, seven, 7-digit numbers, right? Anything right? And three ones are required. Obviously, we know that this place will not contain zero. The problem with this is this will not contain zero. So we have to divide our like solution into two parts. First is when one will be there. If one is there, so we have to now out of six places, right? We have to select two for ones, right? So 6p2, right? Two ones are there, and right, rest of the number could be anything. So obviously this may contain 0, may not contain 0, so everything it will contain as 9. So 4 times it goes for 9, and two numbers will be 1. So first case is 6p2 into 9 to the power 4, right? But the second case, when 1 is not there, right, this place 1 is not there. One, two, three, four, five, six, right? If I'm not putting one there, so obviously one is not there and zero must not be there. So we have only eight option in this case, right? And three ones has to go in, right? These number to 6p3 we have to select, right? And also we have to arrange the number, right? We have to go for the combination of this, right? So 6pc2 or 6c3, we have to select three position for this, right? Repetition is allowed. Again, if you are going with p, then you have to multiply this with factorial 2, right? Or if I'm not going for that, so only c is sufficient for me to go for this, right? So again, I'm going for, so I'm selecting only two positions for this. And this case, I'm selecting three positions, right? Three ones are there. So rest of the places are three, right? In these three places, any number can go, right? Except one, right? So eight options are there. 6c3 is for three places I'm going, and 9 to the power 3 for rest of the numbers. So overall, what answer you are getting? 6c2 C, right? Or multiply with factorial 2, 9 to the power 4 plus 8 into 6 C3, 9 to the power 3. So this completely thing what you are getting, right? See, if you want to see the first case, you can see there, like first place contain ones, right? And rest of the like 7-digit numbers, so 6 digits are there, right? 6 digits we have to fill. Out of this, I'm saying I'm selecting two places, right? Let these two places I'm putting one. So rest of the places are four, right? In these four places, what number we can put, right? So it may be zero, not one, two, three, four, up to nine. So how many options for any like any digit we have? Nine options, right? So nine option, nine option, nine options. So we are saying 9 to the power 4. And in the second case, I'm saying if I'm not putting any one at the first place, so and zero can't go there, right? So how many options we have? To eight options, but three once we have to fill in between. So 6C3, I'm selecting three positions, right? In these three positions, we have to put 1, and rest of the numbers again go with 9 to the power 3. So total is this one. Okay. Now, in this case, if I'm saying like one more question, in how many ways can five identical black balls, seven identical red balls, and six identical green balls be arranged in a row so that at least one ball is separated from balls of the same colors. I guess this is the simplest one. How? See, five identical black balls, seven identical, right, and six identical green balls are given, right? The total number of arrangement in this case will be factorial 18 by factorial 5 by factorial 6 by factorial 7, right? But one case would be there, then all the five identical black balls will be together, seven identical balls will be together, and six identical red balls will be together is only or only factorial 3, right? If I'm taking all at a time, so three cases will be there. So this minus factorial 3. The same number of balls are coming that I'm subtracting from all the cases. So, right, the question was demanding at least one ball is separated, right? So all the cases one ball is separated is coming on this only. And in the previous thing, I said that, okay, the repetition in dictionaries, if required to solve this ranking cricket, right? We have to write down in a dictionary if we are making this, right, cricket in all the respective manners, in how many ways we can arrange this, right? Write down the answer in chat. You can try this dictionary one, ranking one with your name also, right? So we have to make this and because maybe like your name contains the repetition, right? Then it will be good. How many, like if you are writing or making the dictionary with your name alphabets only, so in how many ways we like, what will be the position of your name, so we can just go with that. Very good. See, in the dictionary, if we have to write this C, right, E I K R T. So it's obvious that it will start with C only, right? So first is C, right? Then think on this, CEIKRT, right? Now I have to start with C, then E, then I, then K, then the R, the position, R will take the position, first position, right? So in how many ways this can go? So for coming to R, this is, we have to make the words with C, E, I, and K. So 4 is this, and 1, 2, 3, 4, 5. 5 positioning is there. So 4 and factorial 5 for getting. Now we are with CR, right? CR, and now again C, both the C and R, right? In fact, the first C, right? C and R. Now, after C and R, I has to come, but we know that with C, the second C and E, they both will go into the work. Then the position of I is coming, so I'll be in the third place, right? CRI. Now, obviously, C is coming into this, right? So CRI and C. Done. Now KET, right? But E is at the position left of K. So CRIC. And for this position, it is coming as K, right? For coming K, E has to make this with factorial two ways. Then CRICK and ET is the positioning for this only, right? Plus one, the last position for this. So we can add this and you're getting the number on this. Right, position of cricket, right? After how many word cricket is coming, so we have not to add this number one, right? But what is the position? So we have to add the number one, right? Now, with the repetitions, obviously we have to go, like if I'm giving you 1, 2, 2, 2, 3, 3, 5. How many 7-digit number we can form with the given digits, such that first divisible by 5. Second, divisible by 2. And third, off, right? Maximum 3 minutes you have. Try this. Seven digits we have to make with 1, 2, 2, 3, 3, 5. So obviously, in this case, repetition is allowed, right? Then only we can make 7 digit from these numbers, right? 1, 2, 3, 4, 5, 6, right? So if this is divisible by 5, so unit place must contain 5, right? Now, how many options we have? 3 twos are there, and these 2 threes are there, and 1, right? So 1, 2, 3, 4, 5, 6. These 6 position we have to fill with, right? So factorial 6 by factorial 3, factorial 2. So all the numbers divisible by 5 are there. Okay. For the second one, right? For second, we can say divisible by 2. 1, 2, 3, 4, 5, 6, and 7. Divisible by 2 is unit place is 2. Now 1, 2, 2, 3, 3, 5. 1, 2, 2, 3, 3, 5. 1, 2, 3, 4, 5, 6. 6 options are there for 1, 2, 3, 4, 5, 6. This will be factorial 6 by factorial 2, factorial 2, right? Two twos are there, so repetition of, and two threes are there, so repetition of that, right? When we have to go for the odd numbers, right? This is 1, 2, 2, 2, 3, 3, and 5. 7-digit odd number with the digits 1, 2, 2, 2, 3, 3, 5. In how many ways we can go and write down the numbers, right? See, first, when this will be ending with 1 or 5, right? So 1 or 5, so two options are there, right? And then 1, 2, 3, 4, 5, and 1, 6. Factorial 6 by factorial 3, factorial 2. Uh, three, three twos are there and two threes are there. So total number will be, right, factorial 6 by factorial 3, factorial 2. But case B, when I'm saying this will be ending with 3 only. So 1 we have used there, 1, 3 we have used there, right? And the rest of the numbers 1, 2, 3, 4, 5, 6, but only three twos are there, that's repeating itself. So add both the number, you will get the answer on that. Okay. So arrangement of the numbers in this case. Note down carefully all the threes. Right? And we will get the question on this or the permutation with some condition or conditions. Like if I'm saying we have to write down pencil. Case first, all the vowels in this case are together. Right? Second, no two vowels are together. Case third, all the alphabets are in increasing order as dictionary, right? Means I know ki like E is ahead of C, right? Case fourth, P is always ahead of E, right? Few of the cases are there, right? Not many cases would be there, right? Few of the cases are there that we have to deal. All the vowels are together. pencil, right? First, only two, right? E and I, the vowels. So these two will be together. So 1, 2, 3, 4, and this one is 5. So factorial 5, but E and I can interchange itself. So factorial 2 again we have to take for that, right? So factorial 5 is for, right, E and I together, and the rest are coming for this, right? And second question was ki like no two vowels are together. Obviously, only two vowels we have. So 1, 2, 3, 4, 5, 6. Total is factorial 6. And I'm subtracting the case when the two vowels are together, right? And the most beautiful case is the third case, when all the alphabets are in increasing order as dictionary, right? We know that in dictionary it will come C, right? So something like this could be the order. So arrangement will be like this only. It's in the dictionary. So only like the one fixed arrangement is there, right? As it's dictionary, the all the increasing order, right? But the fourth one, right? This is very important when we are saying P is always ahead of P is always ahead of E. Ahead of means not only one position, maybe two position, three position, and more than that. Pencil, right? Six, one, two, three, four, five, six. E will be ahead of P. So maybe E is there, E would be there, or maybe this E can go to this place, or maybe it can go to this place, maybe it can go to this place. And accordingly, P will adjust into that. P can go, right, accordingly, right? So when we have to treat this, like P will be always ahead of E, not necessarily the consecutive, maybe two place, three place, and so on, right? So how we can go, right? Either we can count this key, okay, if E is at this place, so P has to go from, right, it can start from first place to this place, right? Everywhere it can go, right? So P could be here, right? The places could be 1, 2, 3, 4, or 5, right? So first five places are possible, right? E is here, then 1, 2, 3, 4, 4 possible. E there, 1, 2, 3 position. E there, then 2 position, and E here, then 1 position, right? But 1, 2, 3, 4, right? 4 P 4 we are getting in each and every case, right? So factorial 4 for all the cases, and 5 plus 4 plus 3 plus 2 plus 1, right? So this will be 5 into 4 by 2 job, like we are getting the answer. But look into different way, not counting each way and every time. 1, 2, 3, 4, 5, 6, right? See, P and E, arrangement of P and E is 1, right? If E will be ahead of P. If there isn't any restriction, then arrangement will be factorial 2. So let's suppose I'm saying ki let both are A, right? Both are A of same alphabet or something, right? So total arrangement in this case, like total of this is 6. So this will be factorial 6, and two A's are same. So I'm saying by factorial 2. But when we arrange this, then we are saying, okay, no, I'm giving the name of double A as ahead one is E and like behind one is P. Then you are getting factorial 6 by factorial 2 is the same answer, right? So first we have restricted the movement of P and E, supposing that both are identical. Then at last we have permitted them the one way, like you will be ahead of the second one, so you are getting the answer on that, right? In the same way, right? This is the second way to thought, like we can make the thought of this, right? Anyway, right, if this will not go there, so every time E will be ahead of P, so we will cross this as P and this cross this for E, the P will be there, so the right arrangement will be only one, not two, right? Third, so we can think in this way also, okay, like total number of arrangement will be factorial 6, right? Total number of arrangement is factorial 6. In halfway, E will be ahead, in the halfway, A will be ahead. So factorial 6 by factorial 2 or only 2. You are getting the same answer in this way, right? So lot many things we have to learn in this. So next we'll go with the combination with the restrictions and right. So go through this, right? Start the questions and all, right? I'll send you the question.